argue about Dynamo and generative uh, design for future building. Myself Rajkumar, working as an application engineer with Neilsoft. I do training on softwares and pre-sales postage of Autodesk products. By the name you can understand Dynamo. Dynamo is a dynamic tool and more connected with the other external tools like such as Revit, Neilsoft, Excel and database. And today will be an interesting topic, and will be will let you introduce the Dynamo about Neilsoft, which is established in 1993. We have 800 plus people, company providing specialized engineering services and solution to customer across the globe. The company is headquartered in Pune with pan-India presence and international offices in US, UK, Germany. We are Autodesk Gold Partner, and we do deal with Trimble and Bluebeam softwares. We have our own 100% owned subsidiary-based CAD force, CAD design products, which is our own IP, fully subsidiary of Neilsoft. About today's agenda, what is Dynamo? How is BIM changing the building design industry? What is the link between Dynamo and Revit? How does computation design factor in? And how is it being used in the industry? In simple terms, you can understand how Dynamo will connect to the external tools and how it will improve our efficiency of BIM process, such as like conceptual design and other phases. What is Dynamo? Dynamo is quite literally what you make it. A visual programming language, such as if you are aware of Rhino, Grasshopper, like that it is also one of the visual programming languages. It will have a dynamic link with Autodesk products like Navisworks, Revit, Robot Structural Detailing. It's an open tool, and you can install it in as an add-in for Revit, and it will directly work in with your Revit project and massing environment. More, you can say that by understanding these pictures, you can say more design options you can create with the dynamic properties. At any time you can change the property, it will work dynamically. You can give more dynamic design options. And we have products like Dynamo, which is an open source, and we have a separate product called Dynamo Studio also, which belongs to Autodesk products list, which will be sold separately. What is visual programming? Designing frequently involves establishing visual and systematic or geometric relationship between the parts of design. And simply say, we have this program which is written in C language to add two numbers, which will have a set of n number of codes. The right side we have Dynamo scripting, which is nothing but a visual programming. We are giving just two numbers as the input and it will be added at the end. It's a simple and more easy to understand. As simple as you can say, it is very easy. We know that whatever the project, the regular method it is, we have a systematic algorithm based method. Like for example, if you want to start a project, architecture project, we will start with grids, levels, and how many floors we need, conceptual designing, and after that from the first floor level, creating a wall. So like this, it's a systematic project. We will used to do the same procedure for our next project also. So it is best that you can use as a algorithmic method, define a step-by-step method. You can use the same algorithm for your next project also. It's a process. The input will vary always. You can modify at the input at any time. So we're going to discuss 3 modules in this session. This module 1 we will discuss about understanding Dynamo and the Revit geometry. And this is an conceptual model. You can consider this as an auditorium or otherwise a stadium or seat alignment. For that purpose, we are doing some conceptual design. And we people used to have a control point which is used to control our seating layout depends on the stage. We used to do by using adaptive components. But in this place, a sphere which will move towards any place x in y or z direction depends on the sphere, the control point, the particular sphere, or say maybe say the chair height will be adjusted. We'll see the same step-by-step procedure in massing environment. I'm just starting a fresh mass family, and it's a fresh one, new family. Add-in tab, you can access Dynamo. I'm using currently 0.9 version, Dynamo 0.9. It's a free tool. And I'm just creating a new file. And this user interface very intuitive, and you can say as usual any other software we have file menu and menu toolbars, and the left side of that you can see the libraries, search options. I'm just saving this file as a in one name. The file format it is dyn file format. I'm just giving a name of array of points. I'm just trying to search the node name called point. We just trying to create a point. This is point node. Automatically x, y, z value will be taken as a 0, 0. You can see in the background a point, a black color point it is appearing. The similar way, I'm going to search for a number slider. You can see the point clearly. There are two workspace, front and back. I'm searching for a number slider which will be very easy to give input numbers from ranging from minimum to maximum and steps. And even you can have custom nodes. And this one it is called node, and whatever the connection we are making it is called wires, and automatically the input will be given from the right side of the node to the left side of the node. And even you can have customized node. Just let me start it from the beginning. The same procedure. New. It is easy to connect the nodes. It doesn't require any n number of syntax based codings. These all are the file menus and view menus you will be able to access. And even you can create a customized node. There is a flexibility that you can create customized node, that for example a particular node will create a point from a Excel file, say you can say like that. Otherwise you can create a Python node for the programmer, those who want to access the API. The problem what we used to face it, we are not a programmer, we are normal user. We will be able to access only the modeling part and simple tools. So if you want to access a programming in a much more effective way, you need to know the API. This is a problem, practical problems we used to face. This can be avoided by the visual programming. I'm just creating a double clicking to create a code block. I'm just trying to create a series of numbers for our series of points. And I'm saying 0 dot dot from 0 dot dot and hash number, how many number of points we needed, and dot dot space, what is the space, 1 to 1 space we requires. And it requires, it's saying that error, and the bottom of left corner you can see automatic. It's nothing but it's running automatically. The script will be run automatically, and I'm giving the input for space. The same nodes I'm copying it and then I'm applying the input. The values are from starting from 0 to 12. There are 10 numbers totally, 9 plus 1. I'm giving the same input to the X value. Automatically the 4 numbers, or otherwise depends on your slider movement, it will get increase or decrease. You can adjust any time minimum and maximum value, and you can move forward to that. I'm just trying to create a series of numbers. I'm applying the same XY value, so it will go diagonal, and I wanted to control XY and separately, so it is better that you can copy the same settings and you can connect with the Y value, so that we will be able to control both the values. There are options like short lacing, and in the cross product you will be able to get a series of number diagonally like this. Now we are considering these all numbers as places that we need to create our chairs. At any time these points not all are not created in our backside Revit, which is available only in Dynamo, which is Dynamo geometry. I'm just creating another one point with the control input values like X, Y, Z, and renaming the node with X, Y, Z. And this particular point will control our, will act as a control point, we can say. X, Y, Z. And from all points, the diagonal points and the control point, I'm just creating a line node, and starting point will be the diagonal and the ending point will be control points. From the lines, I'm able to calculate the length of each line. I'm giving the output line information to the curve length value, so that we can able to create a logic that whatever the length of line length, we can apply that as a factor for a future value, say the height of the element or the slope of the component, or whatever the logic we are trying to apply. We just wanted to control our height or the radius. For that I'm applying a multiplication factor, so that it is easy for us to control the radius. In the same center point, whatever the points we have, I'm creating a circle. It's a radius based center point, radius based circle. The points are connected with center point. The radius will be our divided resulted value. This is our logic. So depends on this logic, our depends on our control point movement, automatically the circle radius will be get adjusted. I'm just modifying the circle value. Actually the same thing, same concept will be done in adaptive components families, and which is very difficult that we approximately move our control points from left to right or manually from right to left in x-axis or y-axis. It is very difficult. But it is very dynamic, you can adjust it here, automatically the values will get changed. And the same logic and the dividend logic which is applied to the radius, I'm just going to trying to apply the same thing for the height of the element, for example cylinder element here. I will search for another node called thickness and the surface, which will create our surface and thickness to the element. And the same logic, the number node, you can adjust your height of the cylinder. It's so big, so you can control the value in minimum maximum value so that you will be able to, or otherwise you can apply the logic as like before. You can apply a divided value. You will be able to, depends on multiplication, you will be able to control your height of the element. This is the background. These all elements are belongs to Dynamo geometry, which is not nowhere related to the Revit. Once all geometries are calculated, if it is okay, we can insert that the same geometry into our Revit. I'm just searching for a node. Sphere, so that we can understand depends on, instead of saying depends on control point, we can say depends on a sphere, the height of the element are changing. The sphere radius is nothing but the control point origin. This is the output we will get after adding it. Now you can play around with your values, XY values of multiple array of points and control point. You will be able to see the changes in the model. Again, I just wanted to search for another node which will insert our particular component into our Revit. Direct shape, the node name, it is called direct shape. So it is easy that what we need and we can get the same node. We can search the shape and you can get it. If you need sphere, you can search the node name called sphere. You can check that there is no object in the Massing family environment. I'm just making group for this one for our easy control, for our control point. Direct shape. It requires a geometry, nothing but our created solid geometry, and category. Like in Revit we have categories like furniture, massing, and then assign a category that whatever the component you require. The node name, it is category, and assign a material to that. Material by name. I am just applying a default material which is available in Revit. And it's in manual. Just click the run button so that you will be able to see the model in your Revit. This is it. So now you can modify, even you can modify your model in Dynamo. Automatically it will get reflected in your geometry also. How is BIM changing the building design industry? It is, we discussed about in conceptual design. It is not only in conceptual design, it is more connected with the other phases like simulation, designing, prefabrication, and you can save the file, scripting file, and then you can collaborate with your team. You can send it to other teams also so that they can use the same file to control this model. What is the new challenges are being seen? Increasing need to maintain early design knowledge, increasing need to improve the transition from concept to design, and increasing need for more automation tools to reduce rework. It is important. And increasing need for easier modeling and visualization and analysis tool. How does a computational design factor in? Apply behavior and logic to model. As we said before, all the cases we used to have some logic from starting to end. Apply that logic. Add a visual rule or scripting rule like Python scripting to your model. Build a system, not just a model, and so that you can able to use it in the other project also, and extend to the other application model like Excel in this picture. Why should you consider Autodesk Studio? Key values and benefits like quickly explore the parametric design. The model whatever we created, it is nothing but a parametric model. At any time you can modify the parameter values of radius or diameter one-to-one gap at any time, or otherwise say depends on that value you can able to control the other model element, easily analyze and visualize, and effective work with the project team and other tools. Quickly explore the parametric design concept. It's an iterative method. Whatever the design process or the conceptual design process what we are doing, it's a iterative process. For example, energy analysis you can say, and it will be energy analysis depends on the number of iterative we will do design process, and we will modify the model, and again we will do the analysis. So it's a iterative process. And more likely say the people used to say that we are not following Revit, whatever the settings which is available in Revit. We have our own setup in our Excel sheet. We need to include those settings into our model. These work nowadays, these works are very bit difficult to include, but by using Dynamo like softwares, you will be able to link Excel and model. It is very easy. Solve the complex geometry problems, no programming experience needed. There is no need of accessing knowledge accessing of API, Revit API. You just need to use only these nodes. If you need to create a level node, just use the level node. That's it. And automate the repetitive task for more precision. Say, for example, many people used to do renumbering the value of rooms, or renumbering the space numbers, or type mark. These values are repetitive tasks, and we used to do always by selecting one by one elements, otherwise in schedules. And otherwise some people say 10 out of 2 people will use the apps add-ins from Autodesk. So like room number change, they will be able to use it as much as faster. Say other like Excel import export, 10 out of 8 people will use, and so that they will work with their data more efficiently. And these Dynamo tool will replace all those add-ins, and only one add-in will can able to manage all the repetitive tasks. Easily analyze and visualization geometry, and it is easy that depends on the material or color. We can visualize the for example say panel deviation or sun shading. You can visualize the geometry easily by applying different colors, or by applying different colors or say materials in a shared environment. We mentioned earlier it have link with Revit, Robot, and Naviswork, Rhinos, Excel, Google Spreadsheet, all these applications. Direct link. Effectively work with teams using other tools. It's a design parametric geometry for the Revit family you can create, and you can increase your harness your BIM workflow, the design process. In this module 2, we just considering the conceptual designing will create a exterior building from the uh, shape which is defined in our mass and will be extruded. For the same model, the exterior sun shading will be created. And say for example in the left side picture, you can consider for Abu gate, capital gate building, which will have 18-degree slope, the same way, which is very calculative and intuitive for the building design. And the same logic we can apply for this rectangular geometry, and we'll try to make the same. And even this capital city will start with a circular and triangular shape, and it will go upside with a 18-degree angle, and will have a height of 160 meter. I'm just creating a geometry here, so you can see the geometry on the Revit. It's a rectangular shape, and my Dynamo scripting, it is asked us to select model element. You will be able to select each lines. There are 4 lines. Just click select button. It will ask you to select the model element. Select all 4. So automatically the link will be created between Dynamo and the Revit geometry. If you modify any line in Revit, automatically the Revit geometry also will get affected. If you modify in here in Dynamo, automatically Revit element will get affected. And in this full green color group, which is nothing but element selection, only for element selection and converting those into curve. The curve, all 4 curves are joined as a single curve, and the second orange color group defining the translation in z-axis. I'm just connecting the polycurve output into geometry. It's connected and it's translated in z-axis, and even it is the loft also created, extrusion. Only in z direction. And you can adjust the multiplication value for sine. You can see that you can apply any formula to that. I just applied a sine formula to this so that it is looking like a curve. If you need, you can apply the different formulas. The overall height, it is 586 meter, and you can play with that to reduce and up and down. This particular geometry translate will translate or otherwise move your geometry in XYZ direction. The other node will translate in Y direction with the sine value for our arc purpose for any degree. So I have a degree value as in here 0 to 180 degree, so that it's looking only arc as arc. Even you can change the degree value from 180 to 80 or 100, whatever the value you require. Now it is arc, it is only 90 degree. I'm just trying to make it as arc as 1000. Now the full sine waveform will come like this, up to 1000 degrees. Like this, you can give a different options for a building, and you can apply different computational formula Depends on the computation result, you will get the geometry result also there. Instead of doing manually dragging the curve, you can apply a exact value from your computation. Instead of calculating it in Excel or otherwise some other software and giving as an input, you can directly work with the software. And the resulted solid geometry will be transferred to the Revit geometry as in direct shape, and it will be inserted into our Revit model. If any changes happen in Dynamo, it will reflect in Revit also. And the same second, we're trying to create like this sun shadow for like this shapes, sun shaders. And this is my sun setting. I'm just trying to create sun shadows in this place, this side of the uh, Massing model. It is the normal practice is the people used to create a adaptive component and or otherwise some families, normal generic model families, and they will face difficulties and while placing the component, otherwise modification, otherwise depends on the sun rotation. They have to keep it as a control point and they have to vary. It is very difficult to manage it. I'm just creating it as a model and then I'm selecting face. It will be automatically create your script. The shades will be created. And just the logic, it is very simple. You have to divide the same phase, the selected phase as a number of shaders and increase the thickness, get the isolated line and then increase the thickness of the line and apply that to Revit. It's as much as easier logic. I'm increasing and decreasing the shades count and depends on the design analysis or otherwise later daylighting analysis. You will be able to increase or decrease your number of objects, number of shades, and you will be able to analyze it and come up with some solution. You can give a multiple option, design options. Finally, I'm adding the particular geometry into Revit direct shape geometry. It will be created into your Revit. At any time now, you can able to change the thickness of that particular model. And the second exercise will be creating a different color panel like this, a randomized color panel facade, you can say, otherwise randomized opening in the facades like this. The same we'll try to create it. The same logic, the only the logic it is we have to apply to a material. We have to create a generic model family for panel, and the family will have length and width and thickness of the model and material. We need to apply different material that that is need to be exact the same model value, model panel count, and it will be sent to that particular model. And depends on the phase, the selected phase, the panel count can able to adjust the length and width like this. And just selected the phase, and then the lines are getting divided with length and width. Even you will be able to control the number of horizontal and vertical points. From the line, horizontal numbers and vertical numbers, you can change it. and you can go for the daylighting analysis or otherwise interior lighting. Once it is okay, we can fix the same horizontal and vertical panels. And the particular scripting, the logic it is, we're going to insert a family, a panel family on the particular point. The need for this scripting is we need to apply a different randomized material to the panel, or otherwise randomized height to the panel, and it is not possible easy as in normal way. You have to select each component, the material value you have to change it in the instance property one by one. It is a bit difficult. The randomized material will be applied to the geometry, and the panel length and width can be controlled depends on the surface that we selected. Run it. The panel will be created automatically in this place in your project. The colors, these all are glass panel, glass material with blue, red and green colors. And at any time the thickness of the panel or the rotation of the panel you can control all the values. It is possible to control at any time. All are parametric. In this, that's all about second module. And in module 3, we're going to discuss about working with building data, which is very important. In BIM, we used to have geometry and the building parameter we used to say. For example, a door elevation. The first example is door elevation. Say for example, if you want a door uh, bottom elevation and the top elevation in a plan view, which is not possible. If you need, you have to go for cut for a section and then you have to create a elevation values, markers. So this particular script will be able to create a tag for a door which will show the door elevation, top elevation, bottom elevation in a single tag. For example, consider here the survey point which is available in this place. The level it is in 0, and the project base point it is also in 0, 0. The level based on the project base point. To measure the door elevations, you can go annotate and you can take the spot elevation. In the bottom it is 5. All values are in millimeter, and the top which is in 2139. And if you are trying the same in the right side, in the plan view, which is not possible, which is only possible in the section view elevation views. So I'm trying to create a tag family to that. We have a tag family which consists of 3 parameters, shared parameter for LL and SL, which is nothing but a shared parameter which is used for door as a project parameter in project, and the same tag family, door tag family, which is used as a shared parameter. And from the Dynamo scripting, we trying to make a logic and make a computation from our level. What is the value of the door in the sill height and plus the door height value, and these two value will be added and it will be assigned to the SL and LL value. This is our logic, a simple logic. The script it is already done. I've done, which is very simple script. You have to, from the category list, you have to select the category that is nothing but door category. Select the category, all the elements from that category, and collecting values from the family, which is nothing but level value, level elevation value, and the sill height of the door and height of the door. These all values are collected from the door. The logic, it is very simple, adding with the level height plus sill height for the SL, sill level and level, and adding with the sill level plus level height of the door will give you the LL value. Just connect the resulted value with the value of the set parameter node. The set parameter node will connect you with the Revit parameter in the family. So the value will be automatically updated. You can see the 3 is nothing but a type mark, and 5 is the SL and LL values. 2, 1. The same value will be updated. At any time, if you modify the height of the door, otherwise elevation of the door, these value also will be get updated. This is the advantage of having Dynamo. You can transfer the parameter value from one place to other place. So now this example not only applicable for this. For example, say for the map purpose, bottom of the duct, bottom of the pipe, with the insulation, if you want, you can calculate, or otherwise with the clearance value you need, you can calculate, and you can check it in our tag. A normal tag, bottom of the pipe value will be there without insulation value. If you need with the insulation, you can make some computation, and then you will be able to apply the value to the pipe. As simple as easy exercise it is. The second model, furniture and their room name. For example, we have different rooms. At the end, at the final, say I need to know that the particular furniture in where it is available, in which room it is available, so that we can make a label. At the end of the project, we will be able to assemble it. It is very simple topic, but if you are considering in a bigger perspective like in map, it is very important that to the component room, which room need to be assembled or which room need to be keep it. So these things are very much needed. The same perspective can be served by room calculating point, which is available in each families, and but it is difficult because which is available only in schedule, not in not as a parameter. So we trying to get all the parameters values from which room to which room it is available, and we will put all the values to as a parameter value to particular component for the furniture component in here. Say for example, in this model there are 5 rooms are available, and the right side I have a furniture schedule. I don't have any furniture in this project. I will try to place one component, a table, and I have a room name, which is nothing but a new parameter which is created as a shared parameter and which is assigned to furniture, all furniture in project parameters, only for furniture. If it is required mechanical equipment, you can select it the remaining. So the room names are not filled. The reason it is very simple, the Dynamo which is not running. I'm trying to place other rooms also with some other components like bed, sofas. So all these components, it doesn't have any room name. And in Dynamo scripting, we have to select our room and furniture. We need to check these two values and we're going to check that whether these two are intersecting or not. In room, we will calculate the boundary of the room, and from the furniture, it is nothing but a family, so we will calculate the family location point. This is our rooms, which is created as a Dynamo geometry. Logic to find the room furniture, whether it is inside the room or not, and filtering out only the room which consists furnitures. The same way, you can check that whether intersecting or not. The same logic will be checked for the furniture, whether furniture it is intersecting with that other oppositely to the room. This both filtered out list will be multiplied and will be added to the parameter set parameter value. You can see the rooms. These are the rooms which is filtered out. And this is the condition whether the room which is available inside or not, true or false option. Depends on the true, we will filter it out by using filter by Boolean mask no, which will give only the true command. And the resulted value will be sent to the set parameter. Now you can run. And the room name will be updated in the backside. Automatically it is getting updated with the schedule. Now even you can move your furniture, the room name will get updated automatically. The same logic you can use it for interference checking, and you can place automatically the place where you are having interference. For example, wall with a pipe, you can create a wall opening in the particular place. So it requires a lot of time if you are going with manual. The same application can be used for the schedule and calculated values also, so that our calculated, because every times we used to calculate our brick counts or otherwise bill of quantities, which will be in our schedule, which is not available as a parameter in our model. So you can, the same logic, you can able to transfer the value from one place to other place. The conclusion is very simple. It's more freedom and precision during concept design process and intelligent concept design, and it will improve, simply say that it will improve the BIM process. I'm open to question and answer. If you have any queries, you can type it in your chat window. Can we get the DYN files? Yeah, of course, later from this completion of this webinar, we will be able to send the link for downloading.